Hello, ChemFam. We are reaching one of our final topics for solution chemistry, and that is the colligative properties. We're going to get into this, but basically when you create a solution and you add a solute to a solvent, you actually change some of the properties of that solvent. So let's jump in and see what we're talking about. To define a colligative property, it really is just what the concentration of the solute is in the solvent can create different properties from that original pure solvent. So just by simply adding to water, if we have H2O here, we add some salt to the water and dissolve that in and create a solution. Depending on that concentration of the salt, or the solute in this case, it can actually change the properties of the original water solvent. So let's look at some of those specifics right now. When you have something in a closed container that's a liquid solvent, you have what's called vapor pressure. And what that is really the natural phenomenon of some of that liquid wanting to escape as a gas. But since it's closed off, some of that vapor builds a pressure above the liquid. That pressure above the liquid we call vapor pressure. Now, if you add solute to that, so maybe salt to the water or something like that, all right, by adding more solute and having a higher concentration, the vapor pressure is reduced, meaning that inside this flask, above the water, it's not as high of a pressure. The question is why? It is because since you dissolved solute into the solvent, some of that energy in the solvent that naturally would have been used to escape as a gas from a liquid is now being used instead to surround that solute and try to break it down and dissolve it. So some of the energy from the solvent is now being focused on breaking down the solute instead of turning into a gas and creating that vapor pressure. So something simple, but because it changes, this trait changes because of the concentration of the solute, that's a colligative property. So you can reduce the vapor pressure above a liquid by adding solute. Let's look at another colligative property. This one, boiling point elevation, means that as you add solute to a solvent, you actually raise the temperature at which the object can boil. So again, if you add salt to water, say the water would boil at 100 degrees Celsius. If you add a bunch of salt to that water, you might raise the temperature that the water boils at, I don't know, this is just random estimation, but maybe you raise it to 101 degrees Celsius. Meaning, boiling point elevation means that it has a higher temperature in order to boil. Now, why? Why is this a colligative property? Well, because you add solute, you're taking away some of the energy of the solvent because, again, the solvent is trying to surround the solute and dissolve it. So by having that extra energy focused on the salt, in this case in the water, there's less energy for it to gain, to escape as a vapor and go from liquid to gas, which means that it would boil away. So that raise in boiling point is a colligative property. So just by adding solute to a liquid, you raise its boiling point, meaning it takes an even hotter temperature to boil it. The last colligative property we're going to focus on is called freezing point depression. The last slide talked about how we raise the boiling point. Well, by adding solute to a solvent, you actually lower the freezing point, which means that it has to be even colder to freeze it. You see this all the time in the winter. We throw little cubes of salt out on the streets when it's starting to rain in the winter, and we know that it's going to get below freezing temperatures. So why do we do that? That salt. A lot of people think we throw the salt on the ground just for traction, for more friction, so that cars don't slide. But really what you're doing is when you mix the water with the salt starts to dissolve in the water, and it makes it harder to freeze. So instead of the ice freezing at 32 degrees Fahrenheit or 0 degrees Celsius, maybe it has to get even colder, maybe 28 degrees Fahrenheit or negative 1 or negative 2 degrees Celsius in order to freeze. So by adding solute to the solvent, the temperature at which the object freezes decreases, meaning it has to get colder to freeze. It actually lowers the freezing point. The reason for this is, if we look at water and salt and water, the solute actually gets in the way of the liquid trying to form its crystal solid structure. So we know that when objects freeze, they turn to solid and they get organized in a certain pattern. But if you have chunks of salt in between there blocking it, it actually gets in the way and makes it harder to freeze. So you have to drop the temperature and lower the energy of the solvent even more in order to do that. When we do an ice cream lab, we're actually going to take regular ice cubes, and in it we're going to mix rock salt. So chunks of rock salt around the cubes. By mixing the salt and the ice together, we're actually going to drop the temperature dramatically of the ice cubes, which is going to allow us to freeze the cream and sugar and vanilla to make ice cream really quick with our hands. So we're going to take advantage of freezing point depression, a colligative property, in order to do that kind of lab. So when we get our hands on that and we mix rock salt and ice cubes, you can see how dramatically colder the ice cubes will get once mixed with salt. And that has to do with that colligative property we call freezing point depression. Okay, ChemFam, thanks for listening. This was the main topic, colligative properties. You can lower the vapor pressure. You can increase the boiling point, meaning it needs to have a higher temperature to boil, or you can drop the freezing point, meaning it has to get even colder to freeze. Simple ideas, all have to do with solutions though, because you are dissolving a solute into a solvent. All right, thanks for listening, ChemFam. Take care.